Good morning, and welcome to our continuing outreach series of webinars and on-site seminars dealing with process safety management and risk management program issues, and also the general area of emergency response planning and safety management systems. My name is Steve Maher. I'm with Risk Management Professionals that's hosting this series, and this morning we're going to be focusing on a hazard and operability study facilitation. This is the first module of a 12-module series where we're going to actually go through our 3-day HAZOP study course and share ideas and what we consider best practices so people can get the job done and do good jobs for their companies. A little bit about logistics. This is a webinar, and as such, it is a two-way interactive. We do have to mute the participants who are logging in remotely. Shuffling papers, answering phones, having discussions with your coworkers are something that would be broadcast to everybody else who's on the webinar, and that might be a little distracting. So what we're going to do is run through the presentation. If there are any technical issues, feel free to call the number at the bottom of the screen, 949-282-0123. Somebody will answer and help you out. If you have any interest in posing a question, whether by your name or anonymously, use the chat menu to send it to our producer, Nicole Atramba, and enjoy. Hope you learn a lot with this. Basically, again, what we're doing is focusing on HAZOP study facilitation, and this is the first module of the 12-part series. My name is Steve Maher. My background is my Bachelor of Science is in Mechanical Engineering. Also, my Master's is in Mechanical Engineering, and I've been facilitating HAZOP studies since the mid-'80s, and actually teaching HAZOP studies since about that same time. I'm a professional engineer certified in California as a chemical engineer and also in Pennsylvania as a mechanical engineer. The company Risk Management Professionals, our key services, process safety management. Are you having any problems? Oh, okay, that works fine. The key things that we do are all related to safety management systems work, supporting process safety management, risk management programs, and also safety and environmental management programs for offshore facilities. Key tools that we employ are all phases of process hazard analysis, including the HAZOP studies, which will be the main focus of this continuing series. Our main bases of location are in the West Coast in Southern California and on the East Coast in Philadelphia. The key things that we're going to go through for the series, the first module highlighted in red is what we're going to address this morning. We're going to review regulatory requirements for process hazard analysis, overview the sort of things that you have to do as part of the PHA, look at the tools that are available, and the case study, there's a little logistical problem with the other speaker. That'll be taken care of, that'll be blended into Module 2. The other portions of this are going to be mechanics of the HAZOP study, looking at consequence analysis to the extent that you need it for doing a good quality hazard and operability study, looking at PHA preparation and also getting good quality P&IDs, what's in a good quality P&ID, and how you go ahead and create them so that you can make effective use of your HAZOP study time. And all these tools, techniques, the whole series will be geared towards helping people with the tools and techniques so they can apply it from very simple facilities, perhaps dealing with anhydrous ammonia refrigeration, all the way to very complex refineries. Module 4, we're going to be doing a workshop identifying causes. Laying out the HAZOP study is extremely critical to an effective job, and so we'll have a workshop that actually lays out how you structure the causes for the HAZOP study so you have good scenarios that challenge the team and get the information you want from them. Module 5 are going to be facilitation tips, and also how do you slide the HAZOP study into the project lifecycle. You want to apply different levels of detail at different phases of the project to maximize your return on investment for the amount of money that you're spending for all these people to be in the process hazard analyses and all the team time involved. We'll be doing a workshop on defining scenarios and also common mode failures. And the whole objective is to prevent the kind of accidents that are depicted in some of these photographs that we're inserting. We'll explain why, but the process hazard analysis approach And the tools that we're going to identify are key portions of prevention programs that are designed to prevent accidents. Module 7 goes beyond that a little bit and looks at layer protection analysis, safety instrumented systems, safety integrity levels, quantitative risk assessment, and also how do you effectively integrate that into your HAZOP study. If you plan ahead, you structure it properly and do it right, you can accomplish a lot of objectives by a well-structured and well-implemented HAZOP study that you can use later to apply to these other more complex techniques that involve quantitative assessments of risk. Workshops in terms of how all these fit together will be Module 8. Revalidation. These things aren't static. Every 5 years, maybe more often, you need to update your HAZOP study and process hazard analysis. And there's also an issue of management of change. If there are changes at the plant site, how do you deal with them? How do you weave that back in your PHA? That will be Module 9. Module 10 will be a facilitation workshop. We'll be doing it interactively with the people who join us on site. Module 11, human error, facility siting. These are things that often haven't been done right. There are a lot of checklists out there. The checklists can really bog you down, or they can be really helpful. So we're going to be focusing on that in Module 11. And also Module 12, we're going to be looking at several common configurations of equipment. How do you deal with that with the HAZOP study? And also something that I encounter a lot, there's a lot of use of the term double jeopardy out there. About 90% of the time it's misused. What I want to do is relate how people are using it, how people are supposed to be using it, back to the origin of these things, which is quantitative risk assessment. So those are going to be our key topics for the facilitation series. And as I mentioned, we're going to be focusing on Module 1 today. So let me go ahead and get that set up. Yes, thank you for asking. All right. So we're going to start Module 1. This will take about an hour. There'll be time for questions at the end, and if you see any critical items that you'd like to have brought up during the discussion, feel free to use your chat menu, and our producer, Nicole Trombo, will be glad to take care of that. What I want to focus on are start with the regulatory requirements, why these things exist, what are the basis for the requirements, what kind of things are actually you need to factor into the process hazard analysis, and also then talk a bit about the tools, effective applications, and then spend a little bit more time on hazard and operability studies. Before we get started, the reason why these programs exist is kind of important. It's important to remember that as part of your job, if you're one of the process safety or risk management programs at your company, you have it's part of your job, and it's an important part of your job to implement prevention programs to prevent a lot of the major accidents that have occurred in industry. There's a lot of bad things that have happened, and whenever you dig down into the root causes of that, it always comes back to safety management systems elements, of which process hazard analysis is a key component of that. So what we want to do today is really focus on the things that have been going on, that have occurred in the past, that have prompted these requirements, and then how to effectively implement them and get a good quality PHA. Prior to the 80s, and even more so in 1992, when PSM was promulgated, these were implementation of process hazard analysis and HAZOP studies was a proactive activity that was done within some of the larger companies to primarily protect their investment and also protect their employees. These are things that over the years have been shown to be helpful when they're properly implemented. And a good example that may be going on right now is the Macondo well release that fortunately is mostly under control right now in the Gulf of Mexico. So these things, these major accidents that have occurred, and in fact I made a little list of them here, have continuously brought up the importance of prevention programs and also specifically process hazard analysis. The key events, a lot of these are key items. They're not meant to be in order of importance. They're chronological items of some of the ones that have changed the course of how people look at safety management systems. In 1984, of course, the Bhopal tragedy was a key pivotal event that brought the importance or the potential consequences of major plant accidents in front of the world. and the fact that you could have accidents that not only can injure employees, but also many people off-site. It really changed the way we looked at things. Piper Alpha in 1988, the same thing. These are things that the offshore industry, it was a real wake-up call in terms of the need to address some of these key safety management systems elements. And then, of course, even more recently in 2005, Texas City brought up a lot of issues with respect to facility siting and also mechanical integrity. And just recently this year with the Gulf of Mexico tragedy with the Deepwater Horizon drilling rig, it also brought up the potential for disaster associated with some of our industrial facilities that are out there. Does that mean we need to go non-industrial and shut down? No, what it does mean is that important professionals or professionals who are dealing with safety management systems, if you're the process safety management or risk management coordinator at your company, these are very important activities, and the application of these safety management systems is a critical part of preventing these kind of accidents. Some examples, Flicksboro in 1974, there was a cracked reactor vessel. They did a temporary bypass. The bypass valve, they had a significant explosion. There were a couple dozen fatalities for this. These are things that kind of brought this to the surface for folks. The Texas City event in 2005, basically the omission of procedural steps was identified as a key causal event, failure of safety alarm systems, and also siting issues. The fact that several contractor trailers were located very close by and were not evacuated, or at least taking the personnel out during the key startup of the raffinate splitter that was very close by to the trailers. So these things, again, are key items that keep reminding us of the importance of these prevention programs. If you look at all these items, the impact is significant. Business interruption, lost confidence in contracts, increased regulation. These are all things that come out of major plant accidents. Typical characteristics, if you look at these things, they're rarely not an understanding of the chemistry behind the accident, not understanding the laws of physics, new scientific features that were unknown at the time. Most of them were fairly simple precursors and initiating events that started the chain of events that led to these kind of accidents. Root causes typically were failure to maintain the design intent. This is your first line of defense in terms of making sure the system is safe and safely operating. When something is safe and stable in terms of its operation, it's going to be at the best level of safety for preventing major accidents. So when they took a look at this, the most common mechanism for improvement wasn't by looking at specific actions, throwing blame at somebody, suing somebody, penalizing them. The most effective way to address these kind of accidents was really changing the way business is done. And that's where safety culture and safety management systems came into play. Now, I mentioned before that the Bhopal tragedy really was a pivotal event that really woke the industry up and also the public to the potential for disaster for many of these facilities. Industry didn't sit on its hands. In fact, I was fortunate enough to be part of the technical steering committee with the Center for Chemical Process Safety that was formed right after the Bhopal tragedy. Industry very much took action, jumped on this, trying to realize that managing safety, controlling safety at these facilities was going to have huge benefits in terms of preventing accidents. So in 1985, the Center for Chemical Process Safety was formed. In 1987, one of the first things that came out of that was technical guidelines for technical management of chemical process safety. That was published in 1987, and if you look at the elements behind that, it's not dissimilar from PSM elements, from risk management program elements, from all the things that go into the SEMP program. These are common threads, and we're going to talk more about that shortly, but think about the fact that it was 1987, and you can put together a guidebook that had a lot of these safety management systems elements, and proper implementation of those has been shown and is still shown to be able to prevent major chemical plant accidents. So in a lot of cases, not a lot has changed in terms of us knowing how to control these things. Safety management systems, PSM and RMP, are a key part of that, And a key element, one of the key elements of that is process hazard analysis. That's why we're kicking off this seminar with a discussion of that. Again, an industry initiative in 1990, API recommended practice 750, management of process hazards. Again, these provided comprehensive guidelines, which are still used today as the key portion of the SEMP program for offshore facilities. Although industry jumped on this, there was a need to make sure they were applied uniformly. So there was a need for regulations, and there's, as you know, although a lot of folks in industry may debate this, there is a need for regulators just to keep everybody on an even footing and operating off the same sheet of music. So in 1992, OSHA, what was promulgated that OSHA is now implementing is 29 CFR 1910.119, Process Safety Management of Highly Hazardous Chemicals. February of that year, it's now 18 years later, and it's those same elements and the implementation of those are still a key factor for your prevention program and preventing accidents at plant sites. In 1996, the EPA followed suit with 40 CFR Part 68. That's your risk management program that the EPA administers. And again, we'll talk more about the programs, but their focus is on off-site. OSHA's focus is on-site. It's no coincidence that the prevention program elements of both are common. What the sort of things you do to prevent on-site accidents that can hurt people are also the sort of things for a highly hazardous facility that could lead to off-site consequences too. Again, the key overlap is because of the general nature of these safety management systems and prevention program elements that they are effective in preventing major plant accidents. And again, OSHA's focus is on worker safety, the EPA's focus is on the environment and also community safety, but preventing the accidents and implementing the elements that are common to both are a key part of that. So let's talk about the framework for process safety management that drives the need for process hazard analysis. PSM covers 128 chemicals plus flammable liquids and gases. The focus is on workplace hazards. There are OSHA inspectors, there's an OSHA inspector training program, and there's also inspection instructions. There's really not a lot of secrets here. The kind of things that are required by PSM and the ways to implement them effectively are very well known. The key difference between this and your risk management program is that you're not required to distribute the documentation for this beyond the facility. It's, of course, auditable. OSHA has the right to come in to audit you, take a look at your programs, but they typically will not require things sent to them. The purpose of PSM is to recognize and understand and control deviations from design and operating intent. These are really part of management systems. The idea is that you don't want accidents to repeat themselves, that you want to learn from those. Process safety management is a performance-based standard. Hi, come on in, guys. As a performance-based standard, it's not rule-based. You don't have specific tasks to do each and every time for specific areas. The reason for this is every facility is different. One facility may have different needs than another. Even similar types of facilities, like similar ammonia refrigeration systems or similar refineries, the company is different. The organization structure is different. Because of these differences, you need to look at things on a performance-based, not rule-based, and look at the effectiveness of the program. Okay, it's more effective that way, but it also requires people to be thinking about what really works at their facility and within their organizational structure. Again, a PSM is a set of management objectives. The whole thing is about controlling safety and managing safety. The idea is that major accidents have been caused by unintended change in the past. The idea for PSM is to try to avoid that change and also manage your programs so you can get your desired safety outcome. The key elements are listed here. This is for your reference. The one in red is for process hazard analysis. It's basically part of one cohesive program. Process safety information at the top of the wheel, PHA, process hazard analysis is in green, operating procedures, training, mechanical integrity, management of change, pre-startup safety reviews, compliance audits, incident investigation, emergency planning and response, employee participation, hot work permits, and contractor safety are all part of one comprehensive program designed to achieve those performance-based objectives of keeping workers safe for PSM, and you'll see in a few minutes that these same elements are designed to keep your community safe for RMP. So let's take a look at the risk management program framework. Again, this is a parallel program for PSM, and the idea is that you've got PHA as a key element of that. For risk management programs, it's a different organization auditing it. Also, a key difference is that the EPA requires you to submit your risk management program to them. It's also, portions of that are available for public review. There are ways to control and protect information. Those kind of details I'm not going to go into as part of this module, but it includes, the risk management program includes a number of toxic substances, a lot of flammable substances. Again, it's all designed to achieve and control community safety. Distribution, again, you do have to send materials into the EPA on a periodic basis, and we'll talk about that in a few minutes. And certain things are available for public review. Please note also that depending on what state you're in, that there may be a requirement for state programs to be developed and also submitted to another local regulator for evaluation. Okay, the key elements of risk management plans, hazard assessment, prevention programs, and the emergency response program are all designed to assess what the community impact is, if there is an accident, controlling it with respect to the emergency, and also trying to prevent it. The prevention program elements, the item in black, is what we're going to focus on, and the key portion of that is process hazard analysis. Now, for risk management programs, whether you're dealing at the federal level or with several state programs, there's a couple of different flavors of that. They usually segregate them into programs 1, 2, and 3. Program 1 has very minimal requirements. Program 2 and Program 3 have elements of process hazard analysis required. The wheel on your screen for the prevention program for Program 2 uses a little bit different terminology, and there's a little bit different level of detail. A lower level of detail for facilities that are considered less hazardous and also aren't encompassed by process safety management. Safety information, that's analogous to process safety information. HR, the hazard review element, that's the portion that's analogous to process hazard analysis. For a Program 2 facility, you're allowed to do things a little bit less stringently, but you still, it really makes sense in most cases to apply the same kind of things that you do for a full process hazard analysis for a Program 3 also to Program 2. OP, operating procedures, training, maintenance program, compliance audits, and incident investigation. You'll recognize these, even though this is a more streamlined program in terms of requirements than a Program 3 program, these are important elements and perhaps the most important elements of keeping your program going and your people safe and the community safe at your facility. The items in red, the reason they're in red, these are the things that cause the most citations and violations at different plant sites. Safety information, hazard review, operating procedures, and maintenance are key things that often get people in trouble, get people fined, and it's no coincidence that hazard review and also process hazard analysis are a part of this, given the importance of those elements. And again, that's why this seminar. This wheel for a Program 3 facility, process safety information, process hazard analysis, operating procedures, training, mechanical integrity, MOC, management change, pre-startup reviews, compliance audits, incident investigation, emergency employee participation, hot work permits, and contractor safety. These are very similar to PSM, and when we do programs for people as our part of our engineering consulting services, we try to blend those together so people have a unified program. Again, not a coincidence that the items in red are the key citation elements. These are the things that trip people up the most. Not a coincidence that process hazard analysis is in red, just as hazard review is in red on the previous slide. And also not a coincidence that these key prevention program elements are nearly identical to process safety management. The reason being is, time and time again, is these are the items that have been shown to prevent accidents when properly implemented. Now, let's talk about something else that a lot of folks who aren't in the offshore, who don't have an offshore facility, may not be familiar with. SEMPISEMS, these are offshore programs, safety and environmental management programs, safety and environmental management systems. These sort of things are out there that are designed to apply to offshore facilities. Let's take a look at this wheel. Safety and environmental information, hazard analysis, management of change, operating procedures, safe work practices, training, mechanical integrity, pre-startup reviews, emergency response and control, investigation of incidents, audit of SMP elements, records and documentation. Again, this should look real familiar to you at this point. This is the kind of elements that are in API Recommended Practice 750, also as part of the SEMP program, and also all of these things have analogous elements that are part of PSM and RMP. And this slide, the table on this page is designed to emulate this correlation. Basically, all roads lead to Rome in this case. Again, it's not a coincidence that these specific elements have analogs, whether you're an onshore facility, whether you're an offshore facility, whether you're a refinery, whether you're an ammonia refrigeration facility, whether you're a chlorine disinfection facility, water disinfection facility. It is not a coincidence. These elements are the kind of things that have been shown in the past to be very helpful. And notice that number 2 on the list, hazard analysis, is the sort of thing that's very important for defining what can go wrong at your facility so that you can properly address it. Okay, so there's a requirement for PHA. Well, first of all, even before requirements, companies who wanted to stay on top of their program did HAZOP studies and process hazard analysis. It became regulated in 1992, and it became common, and it's been more and more commonly applied. The importance of that is fundamental to having a good prevention program. It's also important because things do change at your facility to keep it up to date. You want to make sure, because of its importance, that it's updated properly. Now, what I've included here for your convenience, we're going to focus again on the first item there. HR is hazard review. PHA is process hazard analysis. There is a specific regulatory requirement to make sure those are updated once every 5 years because of their paramount importance for defining the scenarios and the sort of things that need to be addressed at your facility. There's also maybe a need if your facility changes, if the organizational structure changes, if your design information changes, if the types of chemicals that you deal with at the plant site change. There may be a need to keep that up to date even more frequently than once in 5 years. Also, just on this list for your convenience, I've listed out other periodic requirements that you want to keep sight of. The RMP submittal itself, the hazard assessment, that's consequence analysis for the consequence and dispersion modeling analysis for those of you who are familiar with it. If you're, for some states like California, external events such as earthquakes can be a significant issue. That's also part of the CalARP program. CalARP is the Accidental Release Prevention Program for California. Again, these are things that need to be updated periodically. Every 3 years, refresher training, compliance audits, and also in California, hazardous materials business plan review. I listed out annual procedures. It's easy for a year to slip by, and gosh, my operating procedures were certified a year ago. It's time to do it again. These sort of things need to be done. You need to ensure they get done annually. These are easy citation items if a regulator comes into your plant site. Emergency action plans or emergency response plans, those may also need to be updated annually. Hazardous materials inventory recertification may also be required annually. Also, non-specific. I mentioned that most facilities are a changing environment, very dynamic. Safety information, process safety information. These are things that define the nature of the hazards at your facility. For that reason, if the nature of your facility changes, those may need to be updated as a key communication tool to your employees, as a key communication tool to the regulators, and also as a key feeder for doing a quality hazard review or process hazard analysis. Maintenance programs. People who don't keep up with their maintenance programs usually pay the price later. These are things that may require some things may require very frequent maintenance. Some things may require infrequent maintenance. It is important to have a program. It's important to stick with what you define in the program. Things that don't get done are easily citable by regulators. Incident investigation, hopefully not. but it may be something that has to get done more frequently. Certainly can't wait to do the incident every 5 years. There are requirements to get this thing kicked off within 48 hours of an event. Management of change, restart of safety reviews, hot work permits, contractor safety elements, and injury and illness prevention programs are all things that may need to get updated periodically. And the bottom in red, keep in mind that all non-incidental changes in design and operation may have other ramifications that affect many elements of your prevention program. So let's take a look at the key requirements of PHA and also the key tools involved. Okay, key characteristics as required by regulation. The citations at the top, you'll recall, 29 CFR 1910.119. Paragraph E is the portion that deals with process hazard analysis. 40 CFR 68, section 67. That's for program 3 elements that defines the requirements of PHA. The requirement there is that the PHA shall be appropriate to the complexity of the process. That means if you have a very simple process, you don't need to do as elaborate a PHA as somebody who might have a complex heavy industry chemical process or refinery. All of them should identify hazards, evaluate hazards, and control hazards, but the level of application, the type of tools used, may differ depending on what kind of facility that you've got. And also, as I mentioned before, Program 2 facilities for risk management programs, those may also be less stringent. So what we're going to do is we're going to focus on PHA. The different techniques that are identified in the regulations as acceptable are what-if, checklists, combinations of the two, hazard and operability studies, which is going to be the bulk of our facilitation series topic, failure modes and effects analysis, also a corollary of that, failure modes, effects, and criticality analysis when you're defining how severe something is, fault tree analysis, and they also allow you to use another methodology if you can justify it. From a pragmatic perspective, you're putting yourself out on a limb for that in terms of justifying it. If you're having a contractor do your process hazard analysis, you want to stick to some of the mainstream elements that are well defined, and also there are various guidebooks for these things. In fact, I'll just put a plug in for the Center for Chemical Process Safety. They do an excellent job putting together guidebooks that help people implement all the various elements of process safety management and risk management programs, and they even help SEMP out, even though there's some corollary documents for the offshore industry. But sticking to mainstream techniques means that later on down the road when you have to update it, it'll be easier to update, it'll be easier for people to understand, and you don't have to justify why you're using some sort of specialized technique. And also at the bottom, there's a little note I want you to always keep in mind: effective applications. Doing a lot of work doesn't necessarily mean you're working smart. All of you know that. Making something effective so that you're finding and hitting on the objectives of this PHA, which are to uncover potential weaknesses and vulnerabilities at your plant site so that you can correct them before the accident happens, is the key objective, and using combinations of techniques or whatever is most effective for your plant site is of critical importance. So this is a list of things that are identified as requirements in the regulations, things that you need to address for the PHA, hazards of the process. Don't forget to look at previous incidents. Engineering administrative controls is a term that may not be immediately obvious to you when you're dealing with process hazard analysis or HAZOP studies. That's usually referred to as a safeguard. Consequences of failures of controls, facility siting, human factors issues, these are critical things to bring into your PHA. And also making sure that you evaluate potential safety and health effects, clearly understanding the consequences and the scenarios that lead to that. And for some state programs, there may be other requirements. For California, that's the bottom bullet. The California Accidental Release Prevention Program also requires you to look at external events. Other regulatory requirements are the composition of the team. We'll talk about that later. There's a requirement for somebody who really understands how to do your HAZOP study, how the system works, how the system is operated. There may be a requirement, there may be a need for maintenance personnel, et cetera. All these things are an important part of doing a good quality job. PHAs, notice the first word there is team. PHAs really, although a lot of people have done failure modes and effects analysis as a single individual, these are usually team efforts. You usually want to bring in different disciplines, people who have different perspectives on your system, so that you can get their perspectives and their inputs so you can have a robust analysis that really can uncover potential vulnerabilities. You also have to have a system to promptly address team findings and recommendations. This is the #1 area where people get cited. When they do a process hazard analysis and your team, a team of experts, who identifies an improvement area to address a vulnerability that's documented, if that doesn't get addressed, that's an easy citation item for a regulator that can say, hey, the team identified a vulnerability, a potential safety problem, why aren't you addressing it? And these are things that are, again, are easily cited, and we'll talk about more a little bit later about recommendation tracking too. Keep that in mind always, whether it be compliance audits, incident investigations, process hazard analysis, or another part of your safety management system program. Addressing team findings and recommendations is critically important. 5-year updates, revalidations, those are also specified by regulation, and also retaining the PHAs and updates for the life of the process. It's useful to you, too, to go back and look at insights that may have occurred in the past. How did you get to where you are? And the current design may also be of critical interest. An easy way to make sure that insights in the past don't get lost is to really build on the previous PHA. I have seen in some cases where a PHA done 5 years ago, it's got all this information in it, and the team doesn't want to assimilate that and deal with it and update it, and they basically put it aside and say, okay, we'll just analyze this fresh. Well, maybe that makes sense. In some cases, maybe the previous PHA wasn't done very well. But if you do that, and there were some critical insights from the team 5 years ago that your team currently didn't pick up on that, you're not only potentially missing an important vulnerability, you also have a smoking gun if that thing ever results in an accident, that it was identified 5 years ago by the team, and now the current team didn't look at it, and you missed a critical vulnerability. An easy way to address that is when you do revalidations is to build on what you did before and make sure that you're constantly building on that body of knowledge rather than just throwing it away and starting again. We'll also be talking more about revalidations during our facilitation series. One of the things I want to have everybody keep in mind are what are our key technical objectives. When you're doing a HAZOP study, you're building scenarios that can lead to accidents. So the way to help understand if there are vulnerabilities is to look at what are the consequences associated with that and how likely is it that you can get there. Just understanding how bad something is isn't going to say it's important or not. Something can be horrible, but next to impossible, and you can say, well, gee, that's not as important as something that is more likely to occur even if it's a little bit lower consequences. Similarly, if something's high frequency, but it's just an operational problem, or it makes your products go off spec, that may also not be a high-risk item even though it's high frequency. So by looking both at the consequences and the likelihood of the event, that will give you an ability to identify importance. So that's what we're trying to do as part of the PHA. Identify potential vulnerabilities, identify potential weaknesses in design or operation, and the HAZOP study approach and these other elements are designed to uncover that. So let's go ahead and look at some of the tools that are out there. This is a spectrum of tools. On the left are the very simple items like a what-if checklist approach. On the right-hand side are more complex quantitative tools, LOPA, event tree analysis, layer protection analysis, event tree analysis, fault tree analysis, are all tools that lend themselves to quantification of the likelihood of the event or how bad it is to get even a better appreciation of risk. These are very useful tools when they're properly applied in a focused manner. We'll talk to you more about good applications later in the series. These tools are going to be, so we like to selectively apply them to very high consequence or high risk scenarios to properly characterize the risk and ensure that the level of safety that's desired by the company is maintained. The areas in green are the more commonly applied tools for medium and high complexity facilities in industry, HAZOP studies, FMEAs, and also there's a 14 API recommended practice 14 series that's been commonly applied and or at least queued for application for offshore facilities. So let's talk more about this animal, the HAZOP study. Hazard and operability study. Really, the title says it all. You're looking for safety problems, and you're also looking for severe operational problems. The application is very creative. It's systematic. It's really easily applied to get a good bang for your buck for most systems. That's why it's in that green area on the previous slide in terms of the types of tools to use. You're looking at both causes and consequences of both hazards and operability problems, so you can really cover the full range and put things in perspective. That's what you're trying to do with process hazard analysis, is put things in perspective. The general objective is to identify facility design or operational recommendations. You want to identify weaknesses, and if there's a weakness that needs to be addressed, how do you address it? That's the key mission for the team. So does that mean you want to redesign the system during the HAZOP study? No. What you want to do is the purpose is to identify vulnerabilities, make sure there's recommendations for how to address it. Addressing it may mean we need to research it more, somebody may need to be assigned to it to research it, or if it's a simple enough fix, like locking open a block valve upstream of a relief valve, then you just go ahead and recommend that, or just make sure it gets implemented. The HAZOP study approach is deductive. You're working backwards from the severe consequence to the specific causes. And also, like I mentioned before, the best applications, if the team is appropriately managed, again, the key focus of our series is HAZOP study facilitation. If the team is managed properly, the team approach can be very effective and can very effectively make use of multiple talents and experience. It can also, as for lots of things and any powerful tool, be very expensive if misused. And if it is properly used, it can provide one of the best PHA values. The HAZOP study characteristics, it's comprehensive, it's thorough, it's very flexible. You can apply it very different phases of the facility life cycle for looking at hazards and also looking at reliability. And also, you can use it as a screening tool for more intensive analysis, such as layer protection analysis or fault trees. When applying it during the facility life cycle, one of the ways that we found that HAZOP studies can be very effectively applied, and we typically use the term HAZOP light for that, although it's kind of a term that we at risk management professionals coined. But early in the design phase, if you do a very light application of a HAZOP study, where you basically look at key causes, key consequences, and do some level of detail associated with the more important items, if you structure it like that, as the design matures, you can take that HAZOP study and just build on it. Add more detail, add more scenarios, and your framework for looking at key consequences just gets built on even further. And so when you're done with the design, you're done with the process hazard analysis, everything meshes, and you've got a very robust ability to address key vulnerabilities that can be very capital intensive early in the design phase. What does that do for you? If you've got a big capital intensive fix, doing it early in the design means that in the long run it's going to cost less. It's always cheaper to make big changes early in the project rather than later. So doing different levels of HAZOP study application throughout the life cycle of the facility can have a lot of benefits, and we will be talking more about that as part of our series. HAZOP studies, self-contained, documented, formalized. These are things a lot of you have seen. A lot of you have participated in HAZOP studies. A lot of you have seen documentation. It can be very effective if it's done properly, and it can also provide a lot of benefits to reliability and also operability at the facility. So what's this what-if checklist thing? Okay, what-if checklist is on our less detailed end of the spectrum that you saw a few minutes ago. It's similar to a HAZOP study in that it examines both causes and consequences. It can look at design or operations vulnerabilities, but it's typically applied at a lighter level, and it can also make use of a team. The checklists that are applied, they can be very helpful to stimulate some interaction, but they also are fairly limited. The HAZOP study provides a little bit better basis for thinking outside the box and brainstorming compared to a what-if checklist. If it's applied properly, again, the HAZOP study, and that's why we're focusing on that for this seminar series, is the HAZOP study approach can be applied in various levels of detail and also make good use of those brainstorming techniques and how you approach a team with that. The next item I'd like to mention is the failure modes, effects, and criticality analysis. As I mentioned earlier, FMEA, please don't write that down as FEMA. That's an entirely different animal, and it's an important agency for the United States. But failure modes, effects, and criticality analysis, or failure modes and effects analysis, FMEA, is also a tool, and we'll talk about it, different applications in a few minutes. It's a component-based process hazard analysis methodology. It does a component-by-component analysis of a system. It looks at the intermediate effects of a component failure modes, so it doesn't really carry it to its ultimate consequences. So it's usually more useful for electronic systems, systems where single failures can disrupt the mission. One example, I don't know if I brought it here or not. Yeah, we'll get into an example in a second, but it's very useful for single failure type systems. It's very thorough with identifying failure modes and sub-failure modes of components, looking at the effects of those failure modes, and also recommending modifications. It looks at the component failure modes, what the causes are, but again, it's looking at intermediate effects, and it usually documents them in tabular form. So it looks a lot like a HAZOP study, and it's very effective for simple systems. And here's an example of one where I did a FMECA several years ago. This is an orbital maintenance system. It was part of a space platform. And basically, when you've got a piece of equipment that's in orbit and single failures that can disrupt the mission of the components can be very critical. And so you want to do a very thorough analysis to eliminate any potential single failures that can disrupt your mission. So FMECA was a perfect application to that. Electronics, aerospace, FMEAs can be very, very useful tools. Let's talk about fault trees real quickly. If you remember from our spectrum, fault trees were at the more complex end of the spectrum, and we're able to put in quantitative information. They're more complex, but they can be very powerful and very useful. You're graphically representing logical combinations of all possible combinations of failures, usually in a block form with various logic elements to combine the blocks. Very useful for calculating standby system unavailability, frequency of accidents, initiating events, being able to graphically depict these in a very thorough fashion, and also for complete accident sequence quantification, very, very helpful. Really good applications are the nuclear power industry, where you've got standby systems that if they become unavailable, you've got standby safety systems. If they're not invoked properly, when you have an accident at a nuclear plant, it can be very critical. Okay, fault tree analysis results. You're looking at the likelihood of the undesired event at the top, and then you're identifying and ranking weak links of the system. Basically, you can start with the HAZOP study or FMECA, constructing the fault tree, qualitatively evaluating it for the scenarios, and then quantitatively analyzing it is the key steps that you use. The characteristics, it's great for identifying all ways the system may fail. It's a good deductive logic approach. You're starting with the top undesired event, and basically you're using two main logic gate types, AND and OR gates. This is a very simple example. On the upper left of your screen, you'll see event A. Undesired event A can be caused by B or C happening. The OR gate means that the likelihood of B added to the likelihood of C can cause your undesired event A. Now, there's some statistical nuances there that I don't want to get into right now, and I believe there's a little bit of a equation underneath there that details that, but essentially it's the sum of the two. For in the case where you've got two parallel systems in the lower right-hand side of the screen, where both B and C would have to fail to cause a failure, the undesired event, which is no flow through the system, which is A. A is caused by B and C occurring. So it's logically depicted with an AND gate, and the way that's calculated is the unavailability of B multiplied by the unavailability of C identifies the unavailability or the probability of the undesired event at the top, A. So a very simple use of OR gates and AND gates in combinations can help you model entire accident sequences. A little representation here, very simple system. Basically, you got a level control valve, and the protection system fails to work. Then you've got your undesired event at the top. When you're looking at the left-hand side at the level control valve, malfunctioning open, a controller failing high, or a bypass valve inadvertently open. These are all potential contributors, so it's under an OR gate. So the likelihood of the valve malfunctioning open, plus the likelihood of the controller failure, plus the likelihood of the bypass being open, gives you the probability of that level control valve being open, and that's the overall contributor to starting this event. So the false rate can be really useful for graphically and logically laying out an accident sequence. The downsides, it can involve a lot more effort, but that effort may be very worthwhile if you need to apply quantitative techniques and really dig down to look at potential vulnerabilities for an important part of your system. So how do you pick what tool to use where? There's a little bit of an art to that, and it really involves an understanding of the tools. Like I said, the most common platform for doing a good quality process hazard analysis, because it's flexible and it can be applied simply, it can be applied at different phases of the life cycle, and it can provide a lot of detailed information that can feed into quantitative techniques such as LOPA and fault tree analysis, is the HAZOP study approach. And that's why it's really good to know that, and it can be very useful as your primary item in your toolkit for process hazard analysis. Picking the right tool randomly, that's not really helpful. This is the wrong way to go about it. So let's look at some of the right ways. Basically, the characteristics of a what-if checklist: straightforward and structured, fairly idea restrictive. You're not as likely to identify new potential hazards, easier to use, faster than an FMECA and a HAZOP study, but it provides less detail. Fewer resource requirements, because it can go faster. You can get at least minimal level of information, and it is an approved tool by both OSHA and EPA for addressing process safety management and risk management programs. Again, because it's limited in terms of what kind of ideas you can come up with, it can provide a bit of a false level of security. Okay, the HAZOP study, as I mentioned, is deductive. It's one of the most effective hazard identification techniques. It can provide a comprehensive investigation of potential hazard and operability problems, and can provide the best assurance, if it's applied properly with the right team, that all hazards have been identified. Also, a key part of that, having the right team and it being applied properly, you also need good quality information. Whenever we go out and do hazard and operability studies, it's very important, whenever process safety information, your P&IDs and other key information isn't up to date, it isn't readily available, that can be a real Achilles heel for the implementation of the HAZOP study approach. Also, what's really nice, future efforts can build on the HAZOP study, and also it's more likely that you're going to uncover complex scenarios. Okay, so I've tried to summarize some typical applications here. Basically, for most process systems and equipment, the first item in blue, HAZOP study is going to be a good general technique to apply. If it's not clear, then another technique will work better. For pipelines, again, very simple systems, a what-if checklist may be more helpful because a good, thorough checklist that looks at all potential things that can go wrong with pipelines might be even more useful than asking a lot of random questions on something that's so simple. Standalone instrumentation, communication, and power systems, and also that orbital maintenance system example that I showed you, an FMECA may be the more important and more useful tool to use. Utility systems. I underlined what-if checklist and also HAZOP studies because it really depends on the system. A very important system that can cause significant damage, such as a lube oil system, may merit the application of HAZOP studies. something that's very simple that may have a much lesser impact, like a nitrogen system or instrument air. Maybe a what-if checklist might be useful for that. So there's no clear answer. It really kind of depends. And whenever we do HAZOP studies for clients, we'll be also applying selectively a what-if or checklist approach to make sure we ferret out the items properly, but it also streamlines our efforts quite a bit. Again, it depends on the system. But mixing and matching is acceptable, and both techniques are listed as acceptable by EPA and OSHA. Offshore facilities, wells, and downhole equipment, well, again, it depends on the complexity. Some systems that may be very high hazard and can cause severe consequences, you might want to know everything there is to know about that system and how well that it works. HAZOP study is a very powerful tool for that. Other systems that may be more associated with pipelines, things like that, even if they're offshore, a what-if checklist might be more appropriate for that. Procedures, what-if checklist is appropriate for that. It's rare that you have to do a step-by-step procedural review, but a what-if checklist can be very useful for helping you do that. Structural elements, again, what-if checklists, and also FMEAs. So we've kind of looked at the range of process hazard analysis techniques. We've looked at where you might apply them, why they're being applied, what are the regulatory requirements that are behind that. The rest of the seminar series is really going to focus on HAZOP studies specifically and exclusively. We're going to show you how to take, this is just an excerpt from P&ID, but information from P&ID along with team knowledge and good facilitation skills, take it, apply various guide words to a deviation matrix combining no and flow to look at no flow issues, more and pressure to look at pressure increase issues. We're going to take you from the P&ID to the HAZOP study deviation matrix. We're going to show you how to apply, how to define nodes, identify process deviations, look at potential causes, look at potential consequences, how to uncover vulnerabilities, how to cycle through and effectively utilize your team's time, and eventually come up with the documentation that you can present, satisfies regulatory requirements, identifies key vulnerabilities, and if necessary, identifies any recommendations to make things better to help you do your job in your prevention program to help keep your employees safe, to help keep the community safe, and also protect the environment. Also listed some references for some of the regulatory citations, for some of the guidance documents. Most of these are readily attainable. The agency documents are, of course, free. The guidance documents, some of the better ones, like I mentioned, are with the CCPS. Those are usually available for purchase online. And that concludes Module 1 of the HAZOP Study Facilitation Series. And as I mentioned before, we'll be reconvening this in early September to have the second module. And at this point, I will take questions. Questions, again, can come from the audience here. They can also come through a chat interface to our producer, Nicola Tromba. And they can also, if you'd like to, she can also unmute you, and you can pose the question to the team or the audience.
So you spoke a lot about
Oh, that's a good idea. See, this means that when you state the question, I don't have to repeat it, and everybody gets to participate. And while you're doing that, I'm going to get some coffee.
So you spoke a lot about the different types of studies to use depending on the application. Have you noticed a certain sweet spot in the team size for the study?
That is a great question, and in fact, we'll be talking a lot about who has to be on the team, and also a lot of those dynamics later. The short answer is 6 is ideal. And well, actually, the best answer is it depends. It depends on the application. I've had HAZOP study teams that were 30 that were just way too big, and I've had teams that were, you have people missing, where you have to, you only have 1 or 2 people, you have to cancel the session because it's not enough. 6 people is about right for interacting and reaching a conclusion. Usually it includes operators, engineers, or people who understand the system and how it works, people who understand maintenance issues, sometimes a project manager, and of course the facilitator, somebody who's leading the discussion and who's trained in terms of what to look for in team dynamics, and also usually you'll have a scribe there. Scribe being somebody who is recording the information, understands about the HAZOP study techniques, is not leading the team, but understands enough about what's going on to properly absorb and capture the information. A good facilitator will know how to use the team, push things forward, so that they're really a critical element of the team. Again, a lot of times, especially if there's been a bad accident, you'll have a lot more interested parties, and your team gets bigger. Sometimes they'll test you. I remember one time it was after a multiple fatality accident in the southeastern part of the United States, and I was called in to facilitate the design upgrade, and they didn't tell the team or me all the details of what happened, and they were trying to find out if, as the team, we would ferret out the kind of scenarios that did lead to those fatalities. The team of 30 that I'm thinking of was not very pleasant. It was when you get more and more people in there, they bring agendas, they bring baggage, baggage of things that they want to dump on the table and things that they want to address that may have nothing to do with the HAZOP study. And getting 6 people to reach a consensus is bad enough. 30 is very difficult, very challenging. Good question. Thank you.
Thank you.
Okay, a question from the audience. Are there any specific training requirements that a facilitator should have?
Great question. This is actually part of a course that we're in the process of getting accredited. And actually the elements of this course, I've been teaching HAZOP studies actually since 1986. The first time I taught this was in January of 1986, and I've learned a few things over the years, but overall the techniques haven't changed that much. Trevor Kletz and Ellis Knowlton are really the fathers of these approaches, and this stuff initially came out in the 70s. Very limited application, of course. It was really by people who were being very proactive, and it wasn't really until the Bhopal tragedy it became more and more applied. And then, of course, once it became promulgated by PSM and RMP, it became even more and more applied. So what you're going to see is you're going to see a lot of people with gray hair that really don't have credentials, but they've got decades of experience. There are a number of courses that are put out by the CCPS. Runs a really good series of training courses that can get you accredited. The course that you're attending right now is something that we're in the process of accrediting, and is also consistent with the way we've taught HAZOP study facilitation to our own personnel and to other people over the years. And hopefully that answered the question. If not, why don't you send another note to Nicole, and I'll elaborate further. All right, well, thank you for attendance. Appreciate everybody's input. And what we'll be doing is setting a date for Module 2. We had a last-minute shift in some other, as you know, Risk Management Professionals does a lot of engineering consulting in the general arena of PSM, RMP, and also the SEMP program. And there's been a lot of interest lately in offshore applications of these safety management systems techniques. So we've had to reshuffle a couple of the webinar series that we were doing associated with offshore, and that impacts our schedule for September. So we will identify a specific date within the next few working days, and all the participants that attended today will make sure you get first notice of that date. So thank you for your participation, thank you for attending, and please feel free to call if you have any other questions.